Hello, I'm Mrs. Edwards, and it is time to do math, and I love it. We're going to be solving some inequalities today, but we're going to be doing that algebraically. But let's start by just looking at the graphs of some functions so we can understand why wholes, vertical asymptotes, and x-intercepts are what we call critical values. So as we look at the graph here on the left, let's just look at where does the graph change sign. In other words, if we are to draw a graph, it's really made out of an infinite number of points that we plot, and those points are coordinates x, comma, y. So if we think about all the points along the curve here, where does the y part of the coordinate change from positive to negative or negative to positive? So what we're going to do here is just first think, what is the y part of the coordinate as we move along from left to right? All those points along there, the y part of the coordinate is positive, right? You would graph backwards and up, so the y part is positive. Now right there on the x-intercept, we would go back 3, up 0, but there's a hole there, so it's back 3 and then undefined. So the y part of the coordinate is undefined. And we continue along, moving to the right, and all of those points in that section, the y part of the coordinate would be negative because you'd go backwards down. So the y part's negative. Right there is 0, 0, so the y part of the coordinate is 0. Continuing on. Okay, all of those points in that section, we moved to the right and then up. And so if we move right up, so positive y coordinates, back to an x-intercept, and that happens to be at 4, 0, so the y part is 0. And continuing on there. And so all the points on the far right-hand side, those ones end up having a y coordinate that is positive because we would move to the right and then up, so up, positive. So let's look at those y coordinates. It starts off with points where the y's are positive, then undefined, and then negative. So one of the places that the graph can change signs is at a hole. Okay, then we continue on, and then we have an x-intercept. Before the x-intercept, the y part was negative, and after positive. So the sign of the y part of the coordinate x, comma, y could change at an x-intercept. And then as we continued on, this next x-intercept right here at 1, 2, 3, 4, okay, that would be 4, 0. The sign of the y did not change before we were above and after we were above. So just because we have an x-intercept doesn't mean for sure we change sign, but it is a possibility. Okay, let's look at the graph here on the right. As we move along the curve and then we get close to that vertical asymptote, eventually we're going to have to pick up our pencil and move to the other side to continue graphing. But so far, all the points on the curve, the y part of the coordinate would be positive. Then we pick up our pencil and start going along the other side, and all of those points along that part of the curve, the y part of the coordinate would be negative. To graph the ones on the left of the y-axis, we went back down, and to the right of the y-axis, we went right down, but in both cases, we're going down. Okay, so we've got negative. Then we go along, continue on, and we get closer and closer and closer to this vertical asymptote, but eventually, if we're going to draw it, we have to lift up our pencil because we have a discontinuity there at 2, go to the other side, and all of those points along there, the y part of the coordinate is positive. So at these vertical asymptotes, the y part of your coordinate can change sign. Okay, all of this is to say that if we're going to be solving inequalities algebraically, The first thing we need to do is go looking for any place that the y could change signs. So our first step is going to be to look for holes, to look for x-intercepts, and to look for vertical asymptotes. So let's take a look at one. Here we've got our first inequality to solve, and the very first thing that you want to do is make sure that everything is on one side set to 0. And this is already true in this one, so we're ready to find the critical values. Finding those critical values, we're kind of pretending that 0 is a y. To find x-intercepts, holes, and vertical asymptotes. But ultimately, to find critical values, the next thing you want to do is replace that inequality symbol, in this case that greater than, with an equal sign. We'll solve this equation, and we're really lucky, right? It's already factored for us. If it wasn't factored, we'd have to use P over Q, so don't forget about that process if you do need to factor it to solve. But now I can just set each piece equal to 0. Solving x plus 3 equals 0, I'm going to end up getting -3. If I went to solve this, this one here, I'd subtract 1 and square root. But if you square root a negative, you aren't going to get a real solution. We're only looking for the real solutions, no imaginary numbers. And then add over 4, and we have 4. Turns out these are our only critical values in this instance, because holes and vertical asymptotes come from rational functions. And remember, to find holes and vertical asymptotes, you look down. Okay, we don't have a denominator, so we can't have any holes or vertical asymptotes. So now that we have all of our critical values, we're going to next make a sign chart with those critical values. That amounts to you making just a general number line, and then you're going to put those critical values in order from least to greatest. So I'm putting in -3 and 4. Next, you're going to take that expression, and that expression comes from, so there's my original, and before I started in on critical values, I would want to make sure everything was set to one side to 0, and whatever's over here, that becomes this expression. Okay, next I'm going to pick numbers from each section and substitute them into this expression. So I'm going to pick a number to the left of -3. I happen to pick -5. Now if I take that -5 and I substitute it in there, I'm going to get a negative answer. You don't care if what the exact answer is, you only care if the answer is positive or negative, which makes it a lot faster. I'm going to do this just one time to illustrate to you how you can do this in your head since you don't care about the exact value. If you substitute -5 into this original and it's factored, well, if you multiply an even amount of an even amount of negatives together, you get a positive answer. And if you multiply an odd amount of negative numbers, you're going to get a negative answer. So if I substitute -5 up in here, -5 plus 3 would have a negative answer. Yes, it happens to be -2, but I don't care about the specific, just positive or negative. So put -5 in there. -5 plus 3 is negative. There's my first negative. -5 squared plus 1, that's a positive. Okay, so I don't care about that. -5 minus 4, that's a negative number, but that negative number is squared. So we're going to have 2 more negatives for a total of 3 negatives. So if we multiply 3 negative numbers together, our answer was negative. Okay, so next I'm going to substitute a number between -3 and 4. I'm going to pick 0, substitute that in there, and we end up getting a positive answer. Okay, then I substitute in 5, any number to the right of 4, right back in there, and when you do that, you get a positive answer. I also want to check my critical values. I do know that if this original was an equal to y, that these numbers would come from x-intercepts. So I already know the answers are 0. But if you don't want to think about it too much, just substitute in those critical values to see what you get. All right, so I put -3 back in there, and -3 plus 3 is 0, and 0 times anything is 0. So when I substitute in -3, I get out 0. I plug in 4, and I get out 0. Our sign chart is complete. So recap of what we've done so far. We made everything, if in the original inequality, everything on one side set to 0, and then we replaced the inequality with an equal sign. We solved that equation. Those are our critical values. We put them on a number line, and then we took the expression that was right here, where it was everything on one side and 0 on the other. All of that is my expression. And then I substitute numbers in each section into that expression to see if the answer is positive or negative, and also substituted my critical values in there to see if the answer is 0 or undefined. You don't have to memorize that, just substitute it in and see what happens. Okay, so finally, we're ready to analyze that sign chart. So you're going back to the original inequality. When you go back to that inequality, you see we have a greater than symbol. So if we were greater than 0, numbers that are greater than 0, those are positive numbers. So we're going to only use the positive pieces from our sign chart. Why is that? One more time, right? We're looking for x is a number. If we substitute a number in for x, and the answer ends up being greater than 0, then that number we substituted in is a part of our solution. So these are the sections where we substituted in x's and we got out positives, negatives, and zeros. We're only looking for positive. So where is that? Look right there, right between -3 and 4, we have positive, and between, or from 4 forever to the right, we have positive. So our answer is going to be -3 through 4, parentheses, because -3 and 4 did not render us a positive answer, union, and then not including 4 through infinity. So if we substitute any x value between -3 and 4, or any x value that is bigger than 4 into this original, we are going to get out a positive answer, greater than 0. Okay, we're going to now just use essentially the same problem so that we can analyze the sign chart a couple times. Instead of just greater than 0, let's change it to less than or equal to, greater than or equal to, and see what happens to our answers. Here we have the inequality that we just found the answer to, and the sign chart that we created for this inequality. And let's use that sign chart to answer this next one, because we would still be creating the same sign chart. Greater than or equal to. If we have greater than or equal to, then we want positive or 0. So looking at that sign chart, where was it positive or 0? Well, it would have been right in here. So we're going to use bracket -3, because when I substitute -3, I get out 0. I'm going to use between -3 and 4, but I'm also going to use 4, so I don't need to break this into two separate intervals, because everything from -3 to the right works. Okay, here's another one. Less than 0 means we're only looking for the sections in that sign chart less than 0. So negative numbers are less than 0. Right in there is the only place where we are less than 0. So every x value from negative infinity until we get to negative 3 will make this original inequality true. And notice I'm leaving out the negative 3 because when I substitute negative 3, I don't get a negative. Okay, one more, less than or equal to. So to be less than or equal to 0, numbers that are less than 0 are smaller than 0. Those are negative numbers or equal to 0. So we're looking for negatives and zeros. So let's look across from left to right. So from negative infinity until we get to negative 3, but negative 3 works because that equals 0. And then we also have there at just 4, it equals 0. Before 4 and after 4, no. So the notation for our solutions, negative infinity through negative 3, bracket because negative 3 is being used, union, but just the number 4. Okay, every x from negative infinity up to negative 3, including negative 3, and the number 4 can be substituted in here, and we will get an answer that is less than or equal to 0. Okay, next we're going to do one more from scratch. So here we go. Here we've got another inequality to solve from scratch. We want to start by finding those critical values. I'm going to replace the inequality symbol, greater than or equal to. I'm going to replace that with an equal sign. And then we're going to focus on finding what would be x-intercepts, holes, and vertical asymptotes if the 0 was a y value. Okay, so if I solve that equation, I could multiply both sides by x plus 3 and x plus 5, and then I'd be able to set the x plus 3 equal to 0 and the x minus 2 equal to 0. And we'd get negative 3 and positive 2. Well, let me just color code that a little bit. Remember when something cancels in the numerator and denominator, there is going to be a hole. So if I solve this equation, I would at first think that the answer was x equals negative 3 and x equals positive 2. But the hole trumps everything, so I know there's going to be a hole at negative 3, and then that means there's only going to be an x-intercept at positive 2. Okay, then I look for any vertical asymptotes or holes in the denominator. And we already know that x plus 3, that's what created the hole because it canceled. So that x plus 5, that must be that's going to be creating our vertical asymptote. So if you set x plus 5 equal to 0, you're going to get negative 5. Now I've run through this kind of quickly because we've already covered finding x-intercepts, holes, and vertical asymptotes. But just a quick recap one more time is to find an x-intercept, you let the y be 0. That's why we have this equal to 0 and solve. And when you do solve that, you would have gotten negative 3 and positive 2. But then to find holes and vertical asymptotes, you look down. And so x equals negative 3, we set the denominator equal to 0, and we get negative 3 and negative 5. But it turns out, right, negative 3 is a hole because it cancels, meaning that we did not have an x-intercept at negative 3. And then we also have a vertical asymptote at negative 5. The big picture here, though, what numbers make the numerator and denominator equal 0? 2, negative 3, and negative 5. Those are all critical values. Okay, next we're going to make a sign chart with those critical values. And so I'm going to put in from least to greatest these critical values, negative 5, negative 3, and 2. I want to test numbers to the left of negative 5, in between negative 5 and negative 3, a number between negative 3 and 2, and then test something to the right of 2. And so let's start off. Negative 10 is to the left of negative 5, so let's use that number. I'm substituting that in right there, okay? And when I substitute in negative 10, I get a positive answer. Okay, selecting a number between negative 5 and negative 3, I'm going to go with -4. I substitute that right in there, and I get a negative. Then I'm going to pick a number between -3 and 2. I went with 0. I substitute that right in there, and I end up getting a negative answer. Okay, select a number to the right of 2. I'm going to go with 3, and I substitute it right back in there, and that gives me a positive answer. Next, I'm going to substitute these critical values into that same expression and see what happens. Now, frankly, some of you can skip that step because you fully understand since -5, right, -5 is a vertical asymptote. When I substitute it in, I'm going to get an error. It's going to be undefined. And -3, there's a hole. So if I substitute that in, I'm going to get undefined because we don't have a y part of the coordinate. And when we substitute in 2, that was an x-intercept, so of course we're going to get out 0. But we can just substitute them in. Okay, -5, fallback plan. Critical values are any numbers that make the numerator 0 and make the denominator 0. These are the specifics, like what they are, x-intercepts, holes, or vertical asymptotes. But if you get stuck, just think what numbers make the numerator and denominator equal to 0 and put those on the number line. Okay, so substituting in -5 back in here, we get 14 over 0. You cannot divide by 0, so that is undefined. When you substitute a number into a function and your answer is a number over 0, not only is that undefined, that's actually telling you as well that that is a vertical asymptote. Okay, let me show you the difference here. If we plug in -3 into here, I end up getting 0 over 0. I know when you were in elementary school and you were the smart one, right? And you got through all the multiplication facts, you did those quick sheets, do 5,000 in under a minute, and then you were given the division ones and they said 0 divided by 0 is 0. Maybe, not always. Okay, 0 divided by 0 is actually undefined. And if you were to substitute -3 in here in your calculator, and you did -3 plus 3 times -3 minus 2 all over -3 plus 3 times -3 plus 5 and hit enter, it's going to say error. Okay, or if you go to Desmos and you use this expression here and you use the table and you substitute in -3, it's going to say error or undefined. Because 0 over 0 is going to be undefined, but specifically, if you substitute a number in and you get 0 over 0, that tells you it was a hole. It's kind of another cool way that you can tell the difference between a vertical asymptote and a hole. Because in the end, they're both undefined when you substitute in the numbers. But specifically, a number over 0 goes with the vertical asymptote, and 0 over 0 goes with a hole. All right, moving on there, I substitute in 2 into that expression there, and I'm going to get 0 over 35, and 0 divided by any number is 0. We've completed our sign chart. So next, we're going to analyze this function to determine the solution. And looking back up here in the original, we have greater than or equal to 0. So what kind of numbers are greater than or equal to 0? Bigger than 0 or equal to 0. Positive numbers or 0. So we're going to look through our sign chart for any x values that generate a positive answer or any x values that generate the answer 0. Okay, well, all of those pieces work. So notice there, to the left of -5, any x value we substitute in generates a positive. Okay, sorry, also, right there at 2, I substitute 2 and I get a 0. And then if I pick any number to the right of 2, I get a positive. So anything to the right of 2 also works. So our final answer is negative infinity up to negative 5. We are leaving out negative 5. And I think that's kind of tricky because students see greater than or equal to and immediately think, oh, all of them are going to be brackets. No. These critical values don't all make this expression equal 0. Some of them make them undefined, and we have to leave those out. Okay, so leaving out negative 5 because when we substituted it did not give us 0. Union, but bracket 2 through infinity because when we substitute 2 we got out 0 and we wanted positives or zeros, and everything to the right gives us positives. Okay, so quick recap one more time, just make sure you have this down. Step 1, move everything to one side of the inequality symbol. Then you're going to find the critical values by changing that to an equal sign and thinking of it as finding x-intercepts and wholes and vertical asymptotes, which really amounts to any x that makes the numerator equal 0 or the denominator equal 0 is a critical value. You put those on a number line, and then you test in each section and also test those critical values. Then analyze by going back to the inequality symbol to decide if you're looking for positives, negatives, or 0. And then keep those pieces and you've got the answer. Okay, good luck.